Hi guys. So today we'll be looking at this question that I don't share. It's not like print it out, so I'll have to write it down as we go. Okay, so we'll be looking at this given function. So what this function does basically is that it gives the greatest integer value of less than or equal to the number inside the function. I'll repeat again. It gives the greatest integer value of less than or equal to the number inside the function. So for example, if you have 8.3, what this function will do is it gives you 8. So it gives you an integer basically. And if you have if you have 7, it will retain 7. And then if you have minus 2.3, it will give you minus 3. Right. Okay. So we established that. And now let's look at the question. Now, we need to draw a graph of what this function would retain, what e to the power x would retain under this function. So basically, we just need to draw the graph basically. Right. Okay. So I'll start with when x equals 0, e to the power 0. So it'll be 1. So if I get 1, then the function will just retain it as 1. So we watch that there. Right. So if I have like 1.2, x is 1.2 or something, I'm not sure, and it gives me 1.2 in the function in e to the power okay, basically when e to the power x will give me something like between 1 and 1.9 xx, I think. Basically what we'll do is it will retain 1 as the answer. So that means we have like a horizontal line, because they'll all be retaining the same value. So now we need to find out when this horizontal line will change. So that's when we have 2. That's when we start getting the function will start giving me an answer of 2. So basically that's when e to the power x will equal 2. So basically x will be log 2. So when x is log 2, that's when the function will shift to something like this. Yeah. I'm not sure how tall this will be, but for now, I think I will do. Then which means the next time it will change will be when it's log 3, then log 4, and so on. You get the pattern, right? Yeah, so basically, yeah, that's the graph. Oh, and by the way, it asks me to sketch for x is greater than or equal to 0. So that. And then the next question says, show that the integral of this, the function, the e to the power side, will give me n log n minus log n factorial. Okay, so basically what integration is just finding the area of the graph between certain functions. So I just need to find, so log n, that's, you keep going on and on, and the steps will keep getting big and big. So I just need to find the area of that. And that way of like log n. Yeah. So I need to find the area of that. So basically I can see that I can quite easily divide these. Then yeah, I'll just see what the area for the first block, second block, third block is, to see if I get any pattern. So if I was to find the area between 0 and log 1, so wait, yeah, that will be, this part is just log 2 minus 0, that's log 2. So that's log 2 multiplied by 1, that's the area of this block. So that's log 2 multiplied by 1, that's just log 2. Then if I'm to find the area between log 3 and log 2, yeah, that will be 2, which is the length multiplied by log 3 minus log 2. Yep. So that's 2 multiplied by log 3 minus log 2. Yeah. And then between log 4 and log 3, that will be 3 multiplied by, yeah, 3 multiplied by log 4 minus log 3. Okay, now, yeah, because that seems like a pattern, so I'll change this one to, because that was 1 multiplied by log 2 minus log 1, because log 1 is 0 here. So I'll write this 1 multiplied by log 2 minus log 1, because that seems to be like a nice pattern for me. Right. Oh, sorry, that's log, yeah, log 2. So I can try to expand it to when I get to. So we have all the other terms in between, and then I'll have log, and I have log n at the end, and then I'll have log n minus 1. So that'll be, okay, so let's use this one. When I log 3, like at the lower end, I'll be multiplying by 3. So which means, then when I log 2 at the lower end of the limit, I'll be multiplying by 2. Which means in this case, I'm multiplying by, no, by n minus 1 here. N minus 1. Okay. Then I just subtract the, yeah, I subtract the limits. So that'll be log n minus log n minus 1. So which means that this integral between log n 0 will be just the sum of all these integrals. Okay, right, so that will be, yeah, basically it's the sum. Yeah, now I need to manipulate this. Okay, so if we add the first two, we don't get any cancellations. Okay, let me try just doing each manual. Log 2 minus log 1, then plus that. Okay, plus 2 log 3 minus 2 log 2. So that'll give me minus log 1 minus log 2. Yeah, I think that's it. Yeah, that's right. What about if I did the first thing? So, yeah, so I have this, obviously. 8 minus, I have minus. Oh, then there's a plus 2 log 3 over there. Yeah, there's that plus 2 log 3. So I have minus log 1 minus log 2 plus 2 log 3 plus 3 log 4 minus 3 log 3. So that'll be minus log 1 minus log 2 minus log 3 plus 3 log 4. So that's between 0 and 0 log 4. Yeah. So if I'm to find the area between 0 and log n, it will mean that'll be minus log 1 minus log 2 minus log 3, then and so on. Because when I had log 4, I was subtracting every term before it's like minus log 1 minus log 2 minus log 3. Then to it I added 3 log 4, which is like, if that was n, if n is 4, that would be plus 4 minus 1 log 4. Yeah. It's sort of, it's like this, plus 4 minus 1 log 4. Yeah. So we got this there. Okay. So that'll be all this. Then below that, before the end, I would have minus log n minus 1, was like minus log 3, n minus 1 is 3. Okay, yeah, that makes sense. Then at the end, I have plus n minus 1 log n. Log n. Yep. Alright. Yeah, I think that the part is established. So that will be 0 x dx equals n minus 1 log n minus log n minus 1, then so on, minus log 1. Yeah, no, let me write it out because it's more easier to visualize if you have the things there. Okay, now I think it's, oh sorry, that's minus log n minus 1 log n. Yeah, that's n there. Now what? Okay, so that'll be n log n minus log n minus log n minus 1, then that'll be minus log n minus 2 dot minus log 2 minus log 1. I want to include minus log 3 because some kind of works. Okay, so we got the first part. So yep, you can ignore that for now and then deal with this other part. So if I take out the negative, yeah, then that'll be log n plus log n plus, so plus log n minus 1 plus log n minus 2, then plus log 2 plus log 1. And then yeah, and then yeah, using log rules, that'll be log, since we're aging, we can now multiply them all together. That'll be log n multiplied by n minus 1 multiplied by n minus 2, and so on until 2, then 1. And then yeah, we got equals n log n equals n log n. Yeah, and then that's n log n minus log n factorial. Plus n factorial just means n factorial equals n multiplied by n minus 1 multiplied by n minus 2, and so on. Yep. Yeah, that's it.